Welcome back to the Cosmic Explorer. Today, we're diving into some of the most common misconceptions people have about physics. From gravity-defying astronauts to the speed limit of the universe, we're about to unravel the truth behind these cosmic curiosities. Get ready to have your mind blown wide open as we journey through the fascinating world of physics and separate fact from fiction. Have you ever looked at astronauts floating in space and thought, hey, there's no gravity up there? It's a common misconception, but let me tell you, gravity is everywhere in space. It's what holds the moon in orbit around Earth, Earth around the sun, and even our entire Milky Way galaxy together. So why do astronauts look like they're floating if there's gravity? The answer is freefall. Imagine yourself inside a giant elevator falling from the sky. If you jumped up, you'd float inside the elevator for a short time, because you'd be falling at the same rate as the elevator itself. That's essentially what's happening with astronauts in orbit. They're not floating because there's no gravity, but because they are in a constant state of free fall around Earth. The spacecraft, the astronauts, and everything else inside are all falling together at the same rate. And since Earth is curved, they keep falling around it, creating the illusion of weightlessness. So, next time you see an astronaut gracefully gliding through the space station, remember, it's not the absence of gravity that makes them float. It's the elegance of physics and the concept of free fall that allows them to dance among the stars. We've all heard the saying, nothing can travel faster than the speed of light. This statement is a cornerstone of Einstein's theory of special relativity. Light in a vacuum travels at about 300,000 kilometers per second. It's the fastest anything can travel within space-time. However, there's a fascinating loophole. The fabric of space itself can expand faster than light. This allows us to observe objects billions of light years away. Where do electrons really live? We've all seen the classic model of the atom, a nucleus orbited by tiny electrons. In reality, electrons exist in a cloud of probabilities, occupying regions called orbitals. These orbitals are three-dimensional regions, where finding an electron is most likely. This concept is crucial for understanding atomic bonding and quantum phenomena. Now, let's know the truth about energy loss. One of the fundamental laws of physics is the law of conservation of energy, which states that energy cannot be created or destroyed, only transformed from one form to another. But there's a common misconception about this law that often leads to confusion. The misconception is that energy is never lost. While it's true that energy cannot be destroyed, it can be transformed into forms that are less useful or accessible to us. Imagine you're driving a car. The car's engine converts the chemical energy stored in gasoline into kinetic energy, or the energy of motion. However, not all of the energy from the gasoline is converted into motion. Some of it is lost as heat due to friction within the engine and between the car's tires and the road. This heat energy isn't destroyed, it's simply dissipated into the environment, becoming less organized and less capable of doing useful work. So, while the total amount of energy in the universe remains constant, the amount of energy available to do useful work decreases over time as energy becomes more dispersed and less organized. Let's demystify the myth of constant force. We tend to think that objects in motion will eventually come to a stop unless a force continues to act upon them. After all, that's what we experience in our daily lives. Roll a ball across the floor, and it will eventually slow down and come to a stop due to friction. But this intuition, while understandable, doesn't tell the whole story. In the realm of physics, there's a fundamental principle known as Newton's first law of motion, which states that an object at rest will remain at rest, and an object in motion will continue in motion with the same speed and in the same direction unless acted upon by an unbalanced force. In simpler terms, objects have a natural tendency to resist changes in their motion. They want to keep doing whatever they're already doing. So why do objects in our everyday experience seem to defy this law? The answer, as we touched upon earlier, is friction. Friction is a force that opposes motion. Whether it's the friction between a ball rolling across a surface or the air resistance an object encounters as it moves through the atmosphere. Thanks for joining us on The Cosmic Explorer. If you enjoyed debunking these misconceptions, hit the like button and subscribe for more content, unraveling the mysteries of physics. Comment with other misconceptions you'd like us to tackle. From the vastness of space to the bizarre world of quantum mechanics, there's always something new to discover. Keep questioning, keep exploring, and most importantly, keep looking up.